Hey everyone, and welcome to our second live session from Quant Masters on the mini series on machine learning, artificial intelligence, and deep learning here live on YouTube. So, I'm Shashank, your technical trainer here for today, where we're going to take a look into machine learning. So, we're going to start introducing the concepts of machine learning. We're going to learn what exactly it is, where is it used, how does it work, why does it work, and so on. So we're going to take a little look at that. Before we begin, my first question to everyone would be, what exactly do you think is machine learning? Think about this. We all have our own definition towards this. We all have our own ideas towards this. A machine which learns, or machine learning is artificial intelligence, or so on. So, in the last session, if you remember, in yesterday's session, we had gone through and we had learned that machine learning is a subset of artificial intelligence. So, it's a way to implement artificial intelligence, in other words. But the question arises, what exactly is it? How do we implement it? The answer is pretty simple. The word machine learning, as it states, is machine and learning. Instead of us as humans learning, we're just having machines learn. That's it. That's all there is. Think of this. Think of this very simple idea. You are giving a machine, that is a computer, images of cats and images of dogs. After giving a computer images of cats and dogs, let's say you give a computer 100 images of cats and 100 images of dogs, and you tell the computer program that these 100 are cats and these 100 are dogs. So the machine understands from it, that is the computer, not the tractor, right? So the computer machine understands from it and it learns from it, knowing that there are 100 images of cats and 100 images of dogs, and it realizes what are the different features of these images. So features is a very important keyword that we keep using when we talk about this. So the machine learning model, machine learning algorithm or application learns what are the features of the images of a cat, what are the features of the images of a dog. Once it has learned, you will then give it one more image and ask the machine to test whether it's a cat or a dog. This time you will not give the answer. This time you're not giving the answer, you're only giving the question whether it's a cat or a dog, and you want your machine to predict whether it's a cat or a dog. This exactly is machine learning. So, to understand this, in short, just to point out, machine learning is where you give a computer program, you give a program some information as follows. You're going to give a particular program input as well as the output. That is, you're giving the program 100 images of cats and dogs, and you're telling the program which 100 of them are cats and which 100 of them are dogs. Once specified, you are then asking the program by giving it one more image and asking the program to predict whether it's a cat or whether it's a dog. So, in other words, all that we are doing here is giving input and output to a program, and we are having the program create its own logic, followed by which we are giving it new input to predict the output by itself. So are we creating our own code here? No. Are we creating our own program to find out whether it's a cat based on whether it has a whisker, whether it has different kind of eyes, whether it has different kind of ears? We are not doing any such thing. We are not creating the logic of the program at all. This is where the magic of machine learning comes in. This is where its advantage comes in. You don't have to code any of this. You literally don't have to do any of this. All you have to do is just give the input and output to the machine learning model, let it learn from it, and then you can predict whether a new image is of cats or dogs. Now, it's not as simple as I make it here, because every machine learning model that you're going to create You're going to need to learn statistics, and you're going to need to implement certain parts of statistics to make sure your program works well. Because there's a good chance your machine learning model may go wrong as well. It can predict a cat as a dog as well. It can go wrong. It can predict a dog as a cat as well. It can go wrong. So that's basically how we get to figure it out. So if this is slightly confusing, let me just give you one small analogy which helps it make superbly easy to understand. Think of a little kid. A little kid has never seen a lion or a tiger. The little kid has never seen a lion or a tiger. So all that you're doing here is you're giving 100 images of lion to the little kid and telling him or her that these are lions. Then you're giving 100 images of a tiger and telling the kid that these are tigers. Once done, you're taking a new image and asking the kid whether it is lion or whether it is tiger. Now, whatever you have done here, pretty much same is what you're going to do in a machine learning application. However, instead of the kid to whom you are giving the images and telling whether it's lion or tiger, it's images with information that you're giving to an application in a computer. That's the only difference that you need to know. This is how we get to know like how exactly a kid is able to learn. A kid may identify certain features in the image, like a lion may have certain kind of hair on its head, a tiger may have different kind of whiskers, and so on, and it figures out. The kid figures out. Same logic applies here as well in machine learning. So I hope now the idea of machine learning is very clear. Unlike typical programming, where input is provided, you create the program to get the output. Here, you're going to give the output and input to the model, which is going to create the program logic by itself. Doesn't it make our work so much easier? Yes. It makes our work so much easier. Now comes a question. If this is what machine learning is, do I see it in real life in every day? You may even get this as an interview question. Where have you seen machine learning in your real life scenario? I'll give you a very small and simple example. We'll take a look at a few applications before we discuss about the types of machine learning. So one of the first application I'm going to take is speech recognition. Think of this. You talk to Alexa, you talk to, let's say, Siri, you talk to your Google Assistant. All of these identify what you're speaking. How do they identify what exactly are you speaking? Using machine learning techniques. Nobody has the patience and time to create code, to create the particular code where if somebody says somebody says code, it should be co and the and e. Nobody creates code like this for every word in English language. And even if somebody manages to write it for every word in English language, think of this. What if somebody has a different accent? What if someone from a different country comes and looks at the program? What if someone from a different country comes and checks out the program? Will it be able to identify that person's speech as well? Possibly no. Because it is created by one person from one country based on how he or she speaks. So this is a near impossible task that takes so much time and effort. Instead, all you have to do is just give a machine learning model the following information. People are speaking certain words, the audio file of it, and what is the word that is there for this audio file. Another audio file, and what is the word that the person is speaking. Give thousands and thousands of audio files and words like this to the machine learning model. Then you speak a new sentence. It will automatically analyze what exactly you're speaking and predict immediately. The moment you use speech to text in your mobile devices, whenever you type and instead of typing, whenever you speak and send messages, or whenever you speak to Google or Alexa, Google Assistant, or Siri, whatever it is, all of them connect to their cloud and use their machine learning algorithms where whatever you speak, audio is sent over there, there it deciphers. There's a machine learning model which has learned from many, many audio files where it has given both of these things. It has been given both audio files as well as the words, that is the output. So when both are given for it to learn, when a new audio file is given, it will convert it to words very, very quickly. That's exactly what happens. So this is why many speech to text softwares you will not be able to utilize when you're offline. It's all based on this machine learning algorithm, which is very huge and stored remotely in a server. This is one example I'm just taking. Think of one more scenario: AI trading. You may have heard of this a lot. Think of this. Whenever we talk about stock markets, it's it has its ups and downs. It can go up, down so many times. Now, can we predict the next day's price? Probably not so well. If I somehow give last 90 days of data, last 90 days of stock market data, for each of the last 90 days, what exactly was the stock or share price of each share, for instance. And can you ask your machine learning model to predict the next day's data? You can. If you create your machine learning model well, if you understand statistics and if you're able to create your machine learning model well, it will predict well, which may end up earning you money. If you go online and search, there are thousands and thousands of AI based trading algorithms that are already there, which basically use machine learning itself. Where a machine takes last 90 or 100 or 200 or 300 days of data, it learns from it only to predict next day's data. This is a part. Similarly, image recognition. Think of this. A lot of real world scenarios have image recognition. Facebook. I'm just giving one example. When you upload an image, whoever are there in your photo, it will automatically identify who they are. And it will ask you, do you want to tag them? How does it figure it out? Again, it has given data before. Your friends' profiles, all pictures of your friend's profile is there with Facebook. With that, it has learned how your friend looks like. So given a new image, it can identify how your friend looks like and immediately tag them in a photo. So you can tell if you want to tag them in your photo or not. So just another example of machine learning where literally all you have to do is give to the machine learning model the right input and the right output, and you have to play around with a little bit of statistics. If you're good at it, you'll definitely be able to do that. Once you're done with this, then your model will be good enough to take an input and predict an output by itself. Again, pointing out that there are no real explicit programming that you have to do whatsoever. Now, similar to this, do you see any other application of machine learning in real life around you? If so, just put it in the live chat. I'll be happy to listen from your end as well. If there are any real world machine learning applications that you think are often used in real life, you can just put them in live chat. We'll be very happy to hear them as well. Apart from this, I'll take one more scenario: medical diagnosis. A machine learning model can be given images of 1,000 X-rays to identify with the next X-ray whether a bone is broken or not, or whether a tumor is present or not. So many scenarios. Instead of having human intervention, there are a lot of real world scenarios where this is used in true today. So medical diagnosis is again a big part of machine learning as well. So by this, I am assuming we have a clear idea of what exactly is machine learning. So simultaneously, if you have any questions, if you have any queries, please do put it in the live chat. I'll be happy to take them up and we will ensure to answer it. We're having these live sessions for a reason, to make sure that we are able to reach you effectively. So taking this examples up, we are now able to understand a few examples. We are now able to understand what exactly is machine learning. But that's not all. Machine learning models or machine learning algorithms are basically divided into three types: supervised, unsupervised, and reinforcement learning. All the examples that I just gave belong to supervised learning category. I'll give you another example to understand what exactly is supervised learning. As the name suggests, it is supervised. That means there's somebody out there to help this model learn. There's somebody out there who is assisting in this model to learn. So I'll give you one simple example. Take your math exams. Of course, I'm taking math, which is not our most favorite subjects, most of us, but that's all right. So let's take math exam. Let's say you learn something about tables. A little kid learns something about tables, like 2 times 5 and from 2 times 1 up to 2 times 10. Similarly, 3 times 1 up to 3 times 10, and so on. So all of these are different things that a kid learns. In the exam, they may give the kid something like 3 times 11. They may give the kid something like 7 times 7. A different question which the kid may have learned, may not have learned. So the kid has to answer them based on what he or she has learned. So a kid learns in prior, that is input as well as output. Then later on, when input is given, so let's say for instance, 2 times 1 is what? 2. This 2 times 5 is 10, so on. A kid learns this. Then when a new input is given, a kid can provide the right answer if they have learned accurately. I have one question that I've received. So ML models is only prediction. Then how accurate can the results be? It's not only prediction. It's not always prediction. You can use it for other purpose as well. I'll explain. Most of the times we confuse the word prediction with other things. Prediction is where you're finding out something nobody else knows. Let's say India and New Zealand are playing a match, for instance, which they are, but I'm not taking that example. Let's say they're playing a match right now. If they're playing a match right now, nobody knows the output, and you're figuring out what the output could be. That's a prediction. On the other hand, you have images of cats and dogs. When you have images of cats and dogs, you 100% know whether a new image given is of a cat or a dog. You know it for sure. So in that way, your machine learning model is not predicting. It's not that nobody knows it. It's just classifying. It's just figuring out whether this belongs to the class of cats or this belongs to the class of dogs. So it's not only prediction, it's also classification. Towards your second part of the question, Santosh, the second part of the question, how accurate can they be? In real world, no machine learning model can be 100% accurate because no real world problem is linear. I'll give you one simple example. If my input is x and output is x square, I will get a line which can easily calculate. If my input is x and output is 2x, I'll get a line where for each x value, it will easily calculate 2x value. This is easily possible. I'm talking statistically. However, when you talk about images of cats and dogs, it's not as simple as that. There are so many pixels. There are so many criteria that you need to work through. So for each machine learning model, you need to specify some statistical features to help the machine learning model give better results. So every machine learning model deals with something called statistics. Statistics to identify error, statistics to identify accuracy, statistics to identify how good the model is, statistics to identify how good an input is. All these things are identified using statistics. Don't worry, these are not differentiation and integration and stuff. These are simple statistics, which most of us don't realize about. That's all. So if you are able to understand statistics and if you're able to provide the right statistical tweaks and parameters to a machine learning model, you can get really, really good accuracy. Think of this: Google's assistant. It's speech to text. Whenever you speak, it has to convert it to text in order to understand, right? Like Google Assistant or Siri or any one of these. Sometimes they may mistake something and understand something else. So they're not 100% accurate. So we cannot always say that they're 100% accurate. That's one thing we should know. So I hope that answers the question. So similar to this math exam, think of this one more scenario. There's certain images of dogs, there's certain images of cats. You're giving that images to a machine learning model to help it learn, just like this exam, where you're teaching a kid tables initially to learn and you're giving new questions. Same way, you're giving images of cats and dogs to the kid to learn, like hundreds and hundreds of images. Then you're asking the kid to predict whether the next image is of a cat or a dog. Based on the previous knowledge, the kid will be able to predict. Same way, based on the previous knowledge learned, a machine learning model is also able to predict. Again, the prediction goes based on what algorithm you use, how you tweak that algorithm, because an algorithm can be modified slightly as well. It depends on all that stuff. I'll give you one more example. This is something we see in everyday life. You can see something called spam and non-spam mails. Every spam mail, like things like, I am the prince of Nigeria, I have $50,000 in my account, but it's frozen. I need your help to give me $5,000 to unfreeze the account. Once you give me $5,000, I'll give you $10,000 back. These are all spam mails. We know spam mails have words like this. So, companies like Google use machine learning algorithms and they give machine learning models spam mails as well as non-spam mails. They give machine learning models spam and non-spam mails, and the machine learning model will learn from this difference. That is, whether a new email is spam or not, depending on the words and the order of words that are there. Hence, it puts something in a spam or it puts something in inbox. Again, it's not 100% accurate because sometimes important mails may also go into spam. So these are some things that may or may not happen. Again, no machine learning model is 100% accurate, but we see that. So this is about supervised learning. So just to point out, supervised learning is where you have input as well as output, both given to the machine learning model in order to learn. Then from the machine learning model, you give only input in order to predict the output. So initially you are supervising and teaching it with both input and output. Whereas an unsupervised learning model is where you don't give input and output both. The best example I can give for unsupervised learning is customer spending. Think of this. Let's say Amazon comes up with a new technique. Their idea is those who spend more, or they want to categorize their customers. So certain customers may have a low income and they may spend high. Certain may have high income and they may spend less, and so on. So depending on how a person is, if a person has high income and high spending, they want to give special offers to only them, for example. So how do they figure that out? In this case, we don't use classification. Here, there is no input and output. Here you have information that there is income and there is spending. Based on income and spend, you want to put them in different categories. So if income is x-axis and spending is y-axis, so there could be some people who have low income, low spending, who may come up here. There could be some people who have low income but they spend high. There could be some people who have high income and low spending. There could be some who may have high income, high spending. There could be some in the middle, medium income, medium spending, or medium income, less spending, or low income, medium income, low spend, or medium income, high spend, or medium income, medium income here, high income, medium spend, or here, medium income, high spend. There could be multiple categories. We don't even know how many categories of customers are there. There could be only two categories also. Low income, low spend, high income, high spend. Other categories may not exist also. So if you don't know how many such categories are there and you just want to group people together, you just want to group elements like this together. So you can figure out how many categories are there and then give different offers to different categories. So if a new person comes up with certain income and certain spend, you can put them in a certain category right here. So when you don't have a particular output, like unlike the previous one, you have cats and dogs images and you're figuring out which one is what, or spam or non-spam, you're figuring out an output. Here, you don't know how many outputs are there. You don't know how many categories are there. So you want to group elements together. That is where we use a particular concept called unsupervised learning. So this is the exact example I took. Low income, low spending, low income, high spending, high income, low spending, high income, high spending. So once it is figured out using this grouping technique, then you can perform more. Or for example, there are images of, let's say, animals and birds. You don't know how many animal images are there, how many bird images are there. You want your application, machine learning model to automatically differentiate animal and bird images. So you give your model, machine learning model, images of animals and birds, and you tell your machine learning model that there are two categories. So it will automatically identify what features are there for animals, what features are there for birds. Like wings are there for birds, four legs generally for animals, on land, on sky, or how they look, and so on. So by that, it will automatically categorize them into two exact categories. So this grouping or categorizing is called unsupervised learning, where you are not giving any output data. You're just telling it to group to a certain amount. Now, the final thing is called reinforcement learning. Reinforcement learning is like a typical old, let's say, teacher. If a student doesn't learn well, the teacher is gonna give student a punishment. If the student learns well, the teacher is gonna give student, let's say, a chocolate. We've seen this, right? If the student learns well, the teacher gives him a punishment, assignments, etc. If the student doesn't learn well, that is, if they doesn't learn well. If the student learns well, they get a chocolate. So this is reinforcement. You're reinforcing the child's brain to work accordingly. So same way, one example I can give here is self-driving cars. Whenever self-driving cars applications are created, a self-driving car is given the option to roam around automatically. When it roams around and it hits something, you deduct a point. When it doesn't hit anything, it goes properly, you increase a point. So it understands the difference between these. Your machine learning model will understand the difference between you giving the negative points and you giving positive points, and it understands and knows what to do. So this is just one example that I'm taking. Another example is artificial intelligence in games. In games, there are some AI characters which know what to do, what not to do. If they get hit, if their health goes low, they won't do such a thing. If their health doesn't go low, they will repeat to do such a thing. So this is often used in many real world scenarios as well. So this is about reinforcement learning. So all that we took a look till now, just to recall before we go ahead, is a bird's eye view of machine learning where we learned what exactly machine learning is. It's where computers are able to learn from input and output and create their own logic where they can create the output according to a new input generally. So this is, there are a lot of examples for this, like speech recognition, artificial intelligence based trading in stock exchange, image recognition, or medical diagnosis, and so on. And we always divide them into three types, three major types. There are further divisions, but these are the three major types we take a look at. That is supervised, unsupervised, and reinforcement learning. Supervised learning is where you have input and output both, which is given to a machine learning model, and you're asking it to classify or predict another output. Even AI trading comes into this scenario where you're giving last 90 days of data and you're asking it to predict the next day's share price. That's also one of the examples. Unsupervised is where you're just dividing inputs into groups. You don't know how many groups must be there, so you can ask and you can divide the data into groups where the machine learning model automatically figures out, depending on different features of images or text, whatever it could be, how many different groups it can be. Reinforcement learning is where you give positive points to any machine learning application or model which does a good task, and when it does a bad task, you give it negative points. That's how it learns. That's how it learns to stop at a stop signal. Whenever a self-driving car moves through a stop signal, you give it a negative point so that it remembers next time it has to stop. This is basically how that works. So this is a small intro to machine learning. So with this, we also want to point out that we have a particular course which is going to start pretty soon on machine learning and artificial intelligence. We have a 3-month internship course. So we've got a 3-month long machine learning internship course that's going to begin from 2nd of December. For any registration details, just check the info of this video. If not, we will be having updated on our website as well. You can go through Quant Masters website and give a check within the weekend as well. If you're interested in learning more about this, we have this huge course planned up very soon. If you'd like to be a part of it and be an expert in machine learning where you can perform your own, you can create your own AI trading application, you can create your own image recognition application, or so on. This would be the right platform to express and work through to learn what is the highest paid industry job right now in the world of computer science. So, with this, I hope you all had a fun time to learn introduction to machine learning, and I hope you guys had a fun time understanding our second of the mini series and getting to know what exactly is machine learning and how it works. With this, we'll catch up in the next session as informed in the info. The details of the entire course will be shared in a couple of days, and you can go through that as well. So thanks for joining us. We'll catch up in the next session of this mini series. Until then, keep learning, stay hungry.